Hello, this is Miss Salter, and this video is going to have some molarity examples in it. This has examples A and B in it. Molarity indicates the number of moles of solute per liter of solution, moles per liter, and is one of the most common units to measure the concentration of a solution. So we're talking about how much solid stuff, although it could be a liquid or a gas. So how much stuff is in a larger amount of stuff. So, it could be solids in a liquid, it could be gases in a liquid. There's a whole bunch of different states of things that it could be in. The ones we're talking about right now are basically solids dissolved in a liquid. And molarity can be used to calculate the volume of the solvent or the amount of the solute. So either the volume of the stuff we're putting in the liquid, or the amount of solute, the amount of solid stuff we're putting in the liquid. So either the volume of the liquid or the amount of the stuff going in it. So we've got one equation here, molarity equals the moles of solute over the liters of solvent. And then we have some conversions. We have 1,000 milliliters equals 1 liter. And then we have to go back to our formula weights or molar masses. 1 mole of solute equals a certain number of grams of solute. So in these examples, we're going to need 2 of these. 1 mole of KCl equals 74.55 grams of KCl, and 1 mole of MgCl2 equals 95.21 grams of MgCl2. So, our first one here is problem A. If we have 1.5 moles of NaCl is dissolved in 2.25 liters of water, what is the molarity? So we're looking here at how much is in this liquid. So what's the concentration? So if you think about it, it's kind of like putting food coloring in water. So if the concentration is higher, the food coloring is going to be very bright and dark, and if very bold, I should say. And then if the concentration is low, it's going to be very faint or very hard to see the coloring in the water. Now, we can't see NaCl or salt dissolved in water, but we can obviously, taste it like in salt water and things like that. So you don't necessarily see the stuff in it, so you can't make a judgment on color. So that's why we had to figure out molarity. So in this one here, we have 1.5 moles of NaCl is dissolved in 2.25 liters of water. So first thing I need to do is get my little pen here and double check. Yep, okay. So first thing I need to do, step number 1, is check my units. Okay, I want to know that my solute is in moles and my solvent, or the liquid, is in liters. If my units are correct, then all I have to worry about is plugging things into my equation. So here I have moles of NaCl. So I have my solute is in moles. That is correct. And my, let's do blue. My solvent is in liters. So that works for me. This is good. And so now I am looking for my molarity. Okay, so if I'm looking for the molarity, then I need M, or molarity, equals my moles of solute over my liters of solvent. Okay, so this is basically step number 2. Step number 2. I'm going to plug in what I have. So, looking for M, I'm going to plug in my 1.5 moles of NaCl. Oops, that's supposed to be a big C. Over my 2.25. That's an awful thing. 5 liters of Mg. No, silly Willy. H2O. Okay, so when I do that division, then I come up with my M equals 0.667 molar NaCl solution. So that's how I say that. 6.67 molar NaCl solution. So that's how much my concentration is for example letter A. Okay. So now I've got this one here. This is B. I'm going to move this one up a little bit so we have him where we need him. So in this one, we're getting a little bit more complicated. I know, I'm sorry. That's just kind of the way it is. Sometimes you're given things that don't quite add up to this whole thing with the units. So first thing we have to do is check our units. Okay, so we want moles of solute. We want liters of solvent. Solute is the solid, solvent is the liquid. Okay, so what do we have here? So we have grams of KCl. So our solute is in grams. So we're going to have to change that to moles. We know how to do that. Not a problem. We have our water is in liters. It is in milliliters. So we have to change that from milliliters to liters. Okay, we can handle this. So, grams to moles. So I then need to do a just a simple molar conversion. So this is 2.4 grams of KCl times, and then up at the top I have my conversion, and it is 74.55 grams of KCl. I'm putting grams on the bottom because I want it to cancel out. This is 1 mole on the top of KCl. So when I do my division, I come up with 0.0322 grams of, no, not grams, moles. No. Moles of KCl. Okay, so now I have that in the proper units, because I need to have my solute in moles. Then I need to get my volume in liters. So I have 600 600 milliliters of H2O times 1,000 milliliters in 1 liter. I want to cancel out the milliliters. They go on the bottom. Liters go on the top. I divide. It becomes 0.6 liters of H2O. So now I have my units correct. Okay, I've got everything converted into the units I need to find my molarity. So now I'm going to go ahead and do step 2, which is my molarity. So step 2, I am looking for my molarity, so I'm doing M equals moles of KCl over liters. Actually, I should put this as a general one. This shouldn't be KCl. Move this up a little bit. This should be solute, and this is solvent. So then we have M equals 0.0322 moles KCl over 0.6 liters H2O, and I do my division there, and so I get M equals 0.0537 molar KCl solution. So when I use the word solution there, I mean that I've got KCl dissolved in my solvent H2O. So this is my concentration of potassium chloride in my water. Okay, so 2 steps. 1, you're checking your units. 2nd, you're using your equation. And I hope you guys, this helps you out. And I'll have another video for example problem C.